Okay students, welcome to topic 3, orthographic projections, and this is part 3 of your 3-part video lecture series on orthographic projections for MM101 Engineering Graphics and Design DFL. Okay, let's recap what we have done so far. We have looked at the basic principles of orthographic projections. We have looked at how the quadrants are made. We have looked at why the first and the third quadrants are the only useful projections. So we have the first angle projection and the third angle projections. And in the previous part 2, we have looked at first angle orthographic projection. Now let's look at third angle orthographic projection. Okay, so let's imagine the box being the same, the glass box. But now this time around, we know this box is now located in the third quadrant. It's no longer located on the top first quadrant, it's now in the third quadrant. So try to imagine where the third quadrant would be and how this box would be located. Okay, so now let's look at this box in the third quadrant and we try to make projections of this solid object onto the planes. Remember, the views that you are getting are actually the projections of this solid object onto the planes. The planes are basically the sides of this box. Now in third angle orthographic projection, the rule is very simple. The plane that you are viewing from, there is the plane on which the views will go. So if you are viewing it from the front, your view will be made on that plane itself. So we say we draw on the nearest plane. Okay, so for example, if I'm looking at this in this direction, looking at it in the frontal direction, then I would have a view, the front view rather, on the nearest plane. And in some cases we like to say that the view or the plane is in between the viewer and the object for third angle projection. Let's look at a the left hand view this time. See, looking at it from the left hand side, the view will be made on the left hand side. Let's get the extra detail there. Okay, so this is how the basic principle differs in terms of third angle projection and first angle projection. In third angle is very straightforward. The left hand view is drawn on the left hand face as well. And the top view, can anyone guess where the top view will go? Yes, exactly. Top view will go right on top. And now that we have the top view as well, now let's look at unfolding this plane. Remember, the top portion of this glass box represents the horizontal plane because it's located in the third quadrant. And when it's going to fold in a clockwise direction. That's going to form something that will be very, very important and give us the third angle orthographic projection. Let's see how it's going to fold up. So we've got the top view, the front view, and we have the right hand side view. Now what's written here is horizontal plane is on the top in the third angle. Okay, so this is the horizontal plane, the one with the top view, is going to open towards us, or you could say it's going to open clockwise. This fold line between the top view and the front view is actually an intersection line between the horizontal and the vertical plane as well. So let's see when it folds up. So when it folds up, this is what happens is when it folds up, this view is what we get. We get the top view on top, the front view, the left side on the left side, the right side on the right side as well. And if you want to go into more detail, you have the bottom and the back view as well. Normally 3 or 4 views are quite sufficient to give details of any mechanical component or part that you want to describe. In certain cases 2 views might be sufficient as well if it's a very simple part. In most of our simple conversion from isometric to orthographic views, we'll be looking at 2 to 3 views. So it's very important for us to understand that how the views are laid out, or how the orientation of the views are in third angle orthographic projections. You have the top view on top, front view, at the bottom. Beside the front view, you have the left side on the left side view and the right side view on the right side as well. Okay, so just quickly recapping the differences between the first angle projection and the third angle projection. The object is imagined to be in the first quadrant in the first angle projection. In the third angle, the object is imagined to be in the third quadrant. Now we see the object is between the observer and the plane in the first quadrant, and in the third quadrant the plane sits between the observer and the object. Okay, and the plane of projection is assumed to be non-transparent in first angle, so we have like a shadow, and in case of third angle of projection we assume it is transparent, so we can see the other side of the plane and project that image onto the plane itself. This is something to remember is the symbol. Okay, look at the first angle orthographic symbol, and that is the third angle orthographic symbol, and this picture here really summarizes it nicely. This is the first angle projection, and you see the viewer looking at the object and drawing it on the furthest plane. Here the viewer is looking at the object and drawing it in the plane right in front, where the plane comes in between the viewer and the object, and you see the difference in orientation of the drawings. Now, which one do we use? The first angle orthographic projection, or do we use the third angle orthographic projection? Well, according to our drawing standards, we're going to use the AS 1100 101, the Australian drawing standards. It recommends that we use the third angle orthographic projection. So that is what we will be using, the third angle orthographic projection. However, it is very important that you understand how to draw in first angle orthographic projection as well, because certain parts of the wall do require that you draw per standard in first angle orthographic projection. So looking here once again, in third angle orthographic projection, this is how the orientation will be. Top view on top, just below the top view you will have the front view, the left side view on the left side, and the right side view on the right side. And obviously do not miss this symbol which will indicate which angle of projection you have.